OSC project, and they're going to tell us about it.
Yeah, we'll just switch between. Yeah, thank you. All right, thank you. Hello, I am Farnaz.
And I'm Matevž. I hope you can hear me in the back row as well. We're both junior research fellows at the University of Tartu, that's in Estonia, but we're not from Estonia, where they are basically studying. So I'm from Slovenia, Farnaz is from Guyana, and we're going to talk about our project.
But first, I have a question for you. Majority of the audience, I mean, some of your students, and well, all of you were students at one point in your life. um, so my question to you is, how many times during your studies, or did you feel like unmotivated to study, or you feel like isolated whilst you had to study? Did you ever have that feeling? Yeah, yeah, most of you, right? Well, what if you had a robot that was there to help you during that process? Well, many studies found like their remote learners and university students, we struggle to find motivation during our studies, right? We feel we need help, we need emotional support during our during our studies and online learning. So we as students, we have many goals to meet, right? We have to keep track of our courses, we have to stay organized, we have to manage our time, we have to stay motivated, all whilst learning and understanding various course materials. And there's this process of isolation and loneliness. And well, I had this thought during COVID, during my bachelor years at the University of Guyana. That's where I'm from Guyana. That's where I did my bachelor in computer science. And it was around that time during my thesis, during COVID, being isolated in my room, that I thought, well, what if I had a robot that's there on my desktop, that's there to keep me motivated through this process? And thankfully, 2 years ago, I completed my master's at the University of Tartu in Estonia, and we built the first prototype of what a study companion robot can be. And right now, I'm continuing for my PhD in this topic. And today, I'll share with you some highlight how it's been going. And what is this RSC, this study companion robot? Well, the first prototype, this is what it looked like. It's a tiny 11 centimeter tall robot, weighs about 380 grams, and it has various multi-model interaction. And it's a low-cost, customizable, open-source study robot that students can replicate on their own. And well, it's OSHWA certified, and we won a few student competition. But Matevž, well, what exactly does it do?
I'll talk about it just now about how it does it, but principally it's just designed to try and express itself. Okay. It's just designed to express itself with various modalities. What do we mean by that? We mean like it can move, so it has some motion gestures, it has some light, there's a button so you can punch the thing and do stuff with it. For example, we use that to engage a conversation. And that touch display, well, aside from issues with some drivers, it's designed to help us navigate some settings menus. But there's more to this story than meets the eye. So Farnaz, do you want to talk about the work that you did for your master's that led to the robot study companion?
So when I got started, I was curious to know, I Googled the term, like as researchers, we went to Google Scholar, type in a few words, but there was nothing that says robotic study companion. There was a lot of, in the field of social robotics, there's a lot of stuff on learning companions, but I spent like 2 months synthesizing literature, trying to get teachers as well as student perspective. There's a lot of research in the social robotics field for primary or pre-university students, but as university students, it's very hard to keep us motivated. So a lot of researchers try to go away with that. So I did what you call a set of literature-derived requirements on what a study companion robot should have, such as it should have multi-model social interaction. As learners, we have different learning methods. Like I prefer to see something so I can learn. Some of you might prefer to listen. So one of the requirement is that a study companion robot must have multi-model social interaction. A second requirement that the user design of it should be easy to handle. It should be obtainable. Obtainable meaning anyone in the world can replicate and have their own. It should have adaptive learning support, reliable, secure, and so on.
So aside from this synthesis, which basically means that you look through what people did, studied, examined, and compiled that into a list of peer-reviewed requirements. This was rejected so many times, and we went so many iterations to get this list down. And on this article, you can actually read the expanded formats for it, etc. It's what led us to then prepare a prototype, an artifact that can meet some of these requirements as a candidate robot study companion. So this is a prototype, and it's a candidate. But how did we actually develop it? We looked at what was there existing. So these are not the papers that we're looking at what the students actually need. These were actual case studies on existing robots. For example, you can see Haru at the lower right. You can see Jiba from MIT. Yeah, and yeah, Haru was Honda Robotics. And then we have Eilik and a couple others. And then we looked at, okay, so they have some interesting design features. Let's see what's common among them and try to brainstorm together how it might impact or look in the concept of the RSC. Then Farnaz took the liberty to try and source the components for them, reusing whatever was possible with permissive licenses. So you can see there's the Raspberry Pi and a nice big 3-inch speaker and lots of lights and 2 cheap servos. Then we tried to embody it. What does that mean? Put it together. You all know the process. And in that point, you can see that we also had to figure out how to connect everything. And then, by iterating, after about 4 cycles, that means 4 times full on, like trying to understand, like, how is it going to work? Is it going to work together? Writing some packages, testing components, and then designing an enclosure for it. We came across, okay, finally, in version 4, there's a viable solution at last. And immediately it fell apart when the reviewer would ask, why don't you just use a smartphone app? Well, in the same research, we found approximately 24 criteria for why people would prefer an embodied intelligent agent, like a dedicated device instead of a smartphone. A smartphone we typically think of as something to communicate with family, go online, TikTok, whatever. It's something that inherently has ingrained itself in our minds to distract us. And this has been so well documented by now in literature. But when you have an embodied agent with a personality that you interact with, that learns about you, you have an opportunity for it to become part of your life, to work with how you work, and for it to basically grow along with you as a separate device that can embody other things. That doesn't mean we can't use an app as well. Of course, we're going to have an app. But trouble came pretty fast. As you know, Google has a tendency to drop projects, and one of the boards that we were relying on is the AIY voice bonnet, which literally 1 month after starting our project went archived, the entire driver. So we had to figure it out with whatever was there, with outdated SSL drivers, try to recompile drivers and even write our own. But the technical depth is so huge for us with a small team with 0 budget and just sheer guts and guile alone to figure this out. So we've decided we're going to try and spin up our own eventually. Okay, Farnaz.
So a little bit about what's been going on for the past year. As part of my research, like the first prototype we developed based on literature, it's what I would like my study companion to look like. But what about other students, right? So I've been trying to play around with different methods, research methods, and so far I was able to try something called participatory design, something called technology acceptance model that I'll share a bit about you. And one of the things that I'm currently focusing on is a cross-culture aspect. Each one of us has different backgrounds, but what kind of personality and behavior would you like in your study companion robot? So currently I have a master's student at the University of Tartu, and she created the digital twin of the robot in ROS 2. And she studied like the different affect the robot must have, such as joy, caring, surprise. And we have these like different scenarios. And we're currently doing testing on this and ethical approval and everything. And so far we did testing at 2 universities, University of Guyana and University of Tartu, where we put students in, we tell them they're in different scenario, and the robot reacted like this, which is like, there's like different colors for different emotion. There is different flipper movements. So this moves. So it either goes sporadic when it's angry, or it goes like happy, and it goes like, so there's different different multi-model behavior for the robot. And yeah, we're trying to understand students from different culture and different background, what kind of expression and personality they would like in their robot. So this is one study that's ongoing. We also did a participatory design workshop last year where we invited students. I just give them one slide and give them some pen and paper. And I was like, hey, I want you to draw what you would like your study companion robot to look like. List 3 features. Tell me one potential ethical and social issue you would like. And as you can see, students have many interesting ideas. One of my students was like, he wants nanotechnology in his, and others were like, I don't need this robot, I just need my computer. So it was very interesting to understand students' various design and background. This study here recently, I had 2 students that I was supervising at the University of Guyana, and not only did they replicate their own in Guyana, so they printed, they obtained all the parts, and they build their own. But they also, we did something called technology acceptance models. So how well do students can see themselves using this robot? And even with a small sample size, we still got some very interesting results. But one of the important part for us was, what are the challenges that these 2 students encounter whilst replicating our solution? Was our documentation in order? And we found that they had like difficulty assembling this robot. There was problem with portability and audio quality. And this is where the second version comes in. And Matevž will be talking about that, right?
Okay, so one big issue that our friends in Guyana figured out, which was obvious to us, but at least they were able to document it, is you have to be an engineer to put one together. You need to know how to solder it, understand pinouts and everything, and even design and build custom little protoboards. So lo and behold, we worked with everything that they documented, and as you can see, there's a bit of a pattern emerging. We're trying to write basically based on papers that are peer-reviewed and open access, build up the documentation slowly and neatly as we go through our academic career as well. So basically, some of the things that they let us know was, for example, that it was incredibly challenging and complex to understand and put together, even though it seems on the surface very simple. So with basically today, what we're presenting is iteration that we built on the current version 4, moving to a 4.1, we call it, I guess, which tries to make it a little bit more intuitive and user-friendly. So for example, the panels are a bit more robust as well. We have access latches now that are with printed place hinges. We have an interesting snap fit construction, for example, the speaker, so it just slots on with a nice seal ring. We added a nice PCB breakout board, even though, yes, the AIY voice bonnet is now technically completely archived and out. We still decided to finish that up. And what else? Yeah, fewer screws and consolidated that as well. If you've ever worked on a project and noticed why does it have many screws, etc., well, we've been trying to get rid of that completely. In fact, we see potential to even make a design that has no screws whatsoever. But that's wishful thinking at this point. Still, we're trying. And it's been a lot of work and a lot of effort to go into this over the weekends and try and manage this, plus PhDs, plus 20-odd students to supervise without any budget on this. It was fun and exciting regardless. Farnaz.
So we recently did a workshop at the University of Guyana, and we had both versions there. And we give it to students. Well, it was a general workshop on social robotics, but we had different prototypes. And it was a three-hour workshop that went on for 4 hours. And we had different student teams, and we gave them the choice if they want to learn 3D designing, if they want to assemble their robot, if they want to learn soldering, and to program the RSCs. For some reason, all the computer science students was like, no, they don't want to program. So that was surprising. They want to assemble their first robot. So we had a lot of teams that was like learning how to put the speaker in, connecting to the Raspberry Pi, put on the hat, how to connect the servos. So it was fun for them. Took them 3 hours plus an extra half an hour to an hour, and then we had to wrap up. But yeah, I mean, it was fun. It was the first time for a lot of university students in Guyana assemble their first robot, learn about the Raspberry Pi, and it was fun. We learned, I collected some data, need to analyze it and so on. But it was fun, and we want to continue making more like RSC making workshops around various universities. Currently, we have University of Guyana. If you some of you don't know where Guyana is, it's on South America. So we have a University of Guyana and a University of Tartu. We have interest in other universities, but it's not replicated there. It hasn't been replicated there as yet. And this is where we invite you. If you're part of a university and you want to be part of our project, we would love to work with all of you. We would love to get you involved. And yeah, you can check out the website, so rc.ee. And generally, we just want to have many students as possible to come on board, learn about robotics, build their own study companion robot, tell us where we can supervise students. But the whole idea is to make it open source, have a community where students can get hands-on and just have fun building, right?
I had conversations outside about what to do with the robot outside of glorified ChatGPT interface. Well, you can put sensors on it, customize them. You can, for example, there's lots of papers that explored the impacts of poor ventilation on cognitive performance. For example, if you're long-term exposed to CO2 levels above, 1,200 ppm regularly, you lose about 30% on your IQ. This is a common thing in the LMIC countries, so low middle income, etc., and in the EU as well. So there's a lot of open opportunities for it to be a glorified Pomodoro timer. If you needed to watch your oven, or it doesn't have a camera, you can spin up your own models on it. It's just a Raspberry Pi. It's a total blue ocean for right now for anybody that wants to come aboard. And yes, you had the map there that was showing where people showed interest so far, focused specifically around universities, so that we start with the use case for basically bachelor students, correct? All right, we're open for questions. We've also prepared some cute QR codes that are keychains printed together. So if you'd like one, approach us, talk to us. And yes, thank you so much.